Hi guys, today we're going to learn about the area of a region between two curves. So to find the area bounded by two functions, let's say y equals f of x and y equals g of x on the interval ab, we want to find this area. How does this look? Okay, so let's say that a is here and b is here, okay? After that, of course, you know that this is your x-axis and this is your y-axis. Let's say that we have two functions, okay? And I'm just going to create here two functions randomly. This is my f, okay, function f, and let's say that this is my function g, okay? So the area that we are talking about in this situation is going to be the area in between, okay, the number a, okay, and b, okay, that it's in between the functions f and g, meaning the area of interest of this situation is going to be this area that I just shaded. Okay, so remember back when we were learning about integrals that the integral is an area. Okay, so what we're looking here is the area from a to b, meaning the integral from a to b of what's going to be here the top secret, okay? It's going to be the upper function minus the lower function, okay? dx, meaning whatever you have that represents f, it's going to be here minus whatever represents g, okay? So it's always top minus bottom, okay? Top minus bottom. And this is with respect to x. Now, you're going to ask me, how about if our situation is not like this and we have something different? Well, to find the area bounded by two functions, whenever you have that x is equal to f of y and x is equal to g, that depends on y over the interval ab, what's going to be this area? Well, let's say that you have here is a, and let's say that you have here b, okay? And in this situation, let's think about, let's think about a parabola, okay? A parabola facing this way, okay? And in this situation, what I have is a line, okay? So I have a line and I care about the line from here to here, okay? And this is my a, okay, and this is my b. So the area of interest in this situation, and excuse me for that, we have a full line here, okay? This is your other function, okay? Let's say that this is g, okay, and let's say that this is f. So the area that you care about in this situation is going to be this area in between those curves, okay? So what's the deal here? Well, this area is going to be the integral from a to b, lower bound to upper bound, and this is going to be, instead of top minus bottom, is going to be right minus left, okay? So which function is on the right, okay? It's going to be f, okay? It's going to be the parabolic situation there, so it's going to be f of y minus g of y, and this integral is going to be dy, okay? So you can see the difference here and here, okay? So it depends on the situation, okay? Basically the variable that you are going to pick for your convenience, okay? You can have both cases, okay? So now please note that for functions of x, we have that the area is going to be a number here, and it's going to be top curve minus bottom curve dx. This is when we have vertical rectangles. What does it mean having vertical rectangles? So if you remember when we were talking about the Riemann sum, we have a bunch of rectangles here. The rectangles are vertical, okay? If you have the horizontal rectangles, you have the same situation in this case, okay? But this is the new case. Your rectangles, instead of being vertical, they are going to be horizontal, okay? They are going to be parallel to the x-axis, okay? So that's the main thing here. Okay, so for functions that depend on y, we're going to have that the area of one number to another number, it's going to be right curve minus the left curve dy, and this is when we have, remember, horizontal rectangle. For this example, we have to find the area bounded by the following graphs. You need to draw the figure and shade the bounded region, and you have here that y is equal to 3 minus x squared and y equals negative x plus 1. So what we know is, I see this one first, and I know that that's a quadratic equation facing down, okay? It's a parabola facing down, 3 units up, okay? So let's say that here you have the 3, okay? So that parabola is going to look like something like this, okay, on this side, and then we have something like this on the other side, okay? So that's your first equation. The second equation that you have over there, that is a linear equation, okay? So you know that it's going to be something around the lines, it's decreasing, and you know that the intercepts are 1, 0, and what's the other one? 1, 0. Okay, so you have a situation that looks like that. Okay, something like this, right? Okay, so what's the area that we care about? Okay, the area that you care about is the one in between. In between these two is going to be this piece that we have shaded here. Okay, for this situation, you do care what's this point and what's this point. So we need to do a mini trip to Algebra 2 where we were solving this situation, this kind of equation. So what you're going to do is you set the 3 minus x squared equal to negative x plus 1 from the equations that we have here, okay? And then you're going to solve for x, okay? Solving for x, you know that this looks like a quadratic equation, so I want to pass all the terms to one side, and here I'm going to choose the right side because I want my leading coefficient to be positive, as you know. So we have this situation, which is very user-friendly because we can factor it out as x plus 1 times x minus 2. With this being said, you can see that what's the deal here? Your x is going to be equal to negative 1 and the second x is going to be 2. Therefore, I can find my first point is going to be negative 1. I would plug the negative 1 here. You know that the y is 2, and then 2 comma negative 2 plus 1, that's going to be negative 1. So score, you have your point. So this point that we have here is going to be the point negative 1 comma 2, and the point that we have over here is the point 2 comma negative 1. Okay, so with that being said, now we can set an equation depending on the area. Now the situation here is, what do you prefer, left and right or top and bottom? Okay, so obviously this one, as you can see, we have a graph that it's completely at the top of the other graph, so in this situation I would do top minus bottom. Okay, so this means that my rectangle, it's going to be a rectangle that it's going to be here. Okay, therefore you have that this is going to be depending on x. Your area is going to be depending on x. So the integral that we're looking for, okay, you are going to look at the x part of your points here. Okay, so it's going to be negative 1 to 2, and after that you are going to do top minus bottom. This guy is at the top, okay, this guy is at the bottom of the situation. Okay, therefore what do you have? You have that it's going to be the integral from 3 minus x squared minus, and then negative x plus 1, close it, and this is going to be with respect to x, so dx. Okay, after that, what I would do here, I would combine like terms and clean up my integral before integrate, so I don't get confused by that situation. So you have that this integral is going to be negative x squared plus x plus 2 dx. Okay, now that we combine all the like terms here, this is positive, that's why it became positive, and then I combine this. Okay, I didn't do anything too extreme here. Now you're going to integrate term by term. Okay, so you know that the integral of this situation is going to be negative x cubed divided by 3 plus x squared divided by 2 plus 2x, and this is going to be evaluated from -1 to 2. Okay? After that, we're going to plug it in, plug the 2 here, okay, and here, and the -1 here and here using the fundamental theorem of calculus. So you know how to do that, so that should be 9/2, okay, and that's going to be the area of this curve. And that's pretty much for this example. Isn't that simple? For this example, what we have is we want to find the area between x equals 5 minus y squared and x equals y minus 1. Okay, so here we have that both equations are depending on y, so the most normal thing here to do is to have an integral depending on y. Okay, the first thing that you recognize, this is also a parabola, but this parabola is facing to the left side. Okay, so you know that the vertex is here where it's 5. Okay, so you know that your parabola is going to look as something like this. Okay, remember, this is just a sketch, a rough sketch, so you have a situation like that. Okay, after that, your equation x equals y minus 1 is going to look as something similar to this situation. Okay, it's increasing. Okay, so you have something along these lines. Okay, so remember, this is a rough sketch. Okay, so the area of interest for this situation, and you know that this is x, this is y, and the area of interest here is going to be this part. Okay, so the deal here is I want to find this point and this point. Okay, so to do that, I need to have my 5 minus y squared set to equal to y minus 1. Okay, and this, in this situation, I'm going to solve for y. Okay, so similarly to the previous one, I'm going to pass everything to one side, making my leading coefficient positive. So you have y squared plus y minus 6, and you know that you can also factor this pretty simple, y plus 3 times y minus 2, and you can see that you have your y's. Y is going to be equal to -3, and the second y, you have that it's 2. Okay, this tells you, well, part of the points that you have. I have 2 points. The first point is going to be something comma -3, and the second one is going to be something comma 2. Okay, so what I would do here, I would plug the -3 here, giving you a -4 here, and the 2 over here, giving you a beautiful 1. Okay, so you know that both negatives is going to be in quadrant 3, so you have that it's -4 comma -3 here, and this guy is going to be both positives. You are in quadrant 1, which makes a lot of sense. Okay, now what's the deal with my integral? My integral is going to be, since I'm using here right minus left, you have that the parabola is on the right side and the line is on the left side. So what you have here is you are going to look at the y. So your area here, it's going to be depending on y. So from your points, you are going to use the y part of your point. Okay, so you have that the lower limit is -3, the upper limit is 2, and then you have right minus left. Who's on the right is going to be the parabola minus the line, which is y minus 1, and this is going to be with respect to y, dy. Okay, now here again we're going to combine. Okay, so you combine your like terms to integrate nicer. Okay, so you have -y squared plus y plus 6. Okay, and you're going to do the dy here. Now you're going to integrate, now that everything is all set and organized, and you have that the integral is going to be -y cubed divided by 3 minus y squared divided by 2 plus 6y, and then you're going to evaluate this from -3 to 2. Remember, you're going to plug the 2 here, 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 minus, and then the -3 here, 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 and that should give you 125 divided by 6. Okay, so that's for this example. example, you have f of x is equal to x to the power of 6 and g of x is equal to x plus 2. They want you to use the calculator. Okay, why they want you to use a calculator? Because you know that this is like having y equals that, y equals that. So they want you to do x power 6 is equal to x plus 2. Okay, when you do that, solving the situation is not simple. Okay, so what are you going to do? Following the instructions, you are going to use your calculator. Okay, so let's go to calculate. Okay, I don't know if you can see my calculate there. Okay, what I'm going to do here, I go to menu, algebra, and please make sure that you have a CAS calculator here. You are going to press solve. Okay, at solve you are going to do algebra. Okay, solve, and then you have that's the solver. Okay, so it needs to be solved. If it's unsolved, that's not going to be enough, and you're going to see why. Okay, so x to the power of 6. Okay, you have that it's going to be equal. Let me erase that one, so watch out with that. Make sure that the cursor is blinking the whole thing. So that one is the one that I like. Okay, and that's going to be equal to x plus 2, right? Okay, so since we're solving with respect to x, I'm going to put comma x. Okay, so as you can see, you have the comma x there. Click enter. Okay, so we have 2 points. Okay, remember you need to use at least 3 decimal places. Okay, so we have that my solutions are, let's record it. Okay, so since we want to solve for x, my x is going to be negative 1, excuse me, and the second x is 1.2148 what else, 6 ... Okay, so it was that one. Great. Okay, so what do you have when we graph it? When you graph it, I don't need the calculator for that, honestly. Okay, you can use it if you want, but we don't. Okay, so what you have is you have like this one. Since it's even, you have that it's going to look kind of like a parabola. So you have a situation like this, then you have a situation like this. Okay, so that's going to be f. Okay, then you know that g of x is going to be a linear equation. That's nothing new for you. Okay, so you have a situation that looks like something like this, right? Let's kind of like do it evenly, something like this. Okay, it's increasing. Okay, so let's say that this is your negative 1. Okay, and that's my positive, what was it, 1.2148 ... Okay, so that's the area that we want. This is the area that we want. Okay, so you're wondering what's the area that we want. That's the area that we want. Okay, so the area, actually I don't need the y's. Okay, so in this situation, because I'm seeing that it's going to be top minus bottom, the top is going to be the linear equation, which is g, and then the bottom is going to be f. So I know that this expression is going to be the area with respect to x is going to be equal to 1.24, okay, ... Okay, and then you have that the equations here are going to be what? Well, it's going to be top, which is g of x, x plus 2 minus, and it's going to be x power 6 dx. Okay, so at this point, what are you going to do? You're going to plug this in the calculator. Okay, so to do that, what you can do is I would just copy all of this. Okay, you can copy all of that in your calculator. I mean, you can record it or not. Okay, so you have that. Then I would go to menu. Okay, and you can go to calculus. Remember, then you go to integral. Okay, and then I would put the negative 1 here, and then over here you have the 1 point, and then I have 21486 23 22484. Okay, and then here you have that it's going to be x plus 2. I don't know why I put minus, plus 2 minus x power 6. Okay, and then you have that one you want it with respect to x. and that's your integral. Okay, so you have that this situation is going to be equal to 3.96667, which obviously you can round it to 7, and that's pretty much it for this problem. Now for this example, we want to set up the integrals needed to find the area of the shaded region. You're going to be like, why in the world is the shaded region? First, let me shade the region. Okay, this is going to be the shaded region. Okay, so what you can see here is I have two situations. Okay, let me use color so you can see the difference here. Okay, I have this area, okay, the pink one, and I have this yellow area over here. Okay, so I have three intersections. Okay, let's call the intersections, I'm going to call this point, let's call it A, B. This point over here, let me put an arrow there. This one is going to be very original, CD. How about that? And this one, I'm going to call it HK. Okay, you're going to tell me why you didn't call it EF. It bothers me to call something E, you know, because of Euler's number. Okay, so having those points, okay, that we just create, what's going to be the deal? Okay, so from the pink one, you have that G of X is the top, F of X is the bottom. Do you see it? Okay, hopefully you do. Okay, so the area here with respect to X, because we're using top and bottom, is going to be what? From A, okay, to C, because I'm using the X parts of the point, okay, and then you know that it's going to be G, okay, of X minus F of X, okay, dx. That's the pink part. Okay, all of this pink. Okay, that's the pink part. But we also want the yellow part. They are telling you the area of the shaded region. Remember, even though both have different colors, everything is shaded. So you're going to do plus, okay, and do another integral. This integral, again, you do have top and bottom. Okay, but the situation here is that the top function here, okay, as you can see, is f of x, and the bottom function is the g of x. So here, okay, you are going to use from C to H, because you are looking at the x part of the points, and then your top here is going to be f of x minus g of x dx. Okay, so this is pretty much the yellow part. Obviously here, since we don't know the functions and a lot of things, we are just going to leave it like that. But this is a beautiful example where you can see that it gets a little bit messy because there are several intersections of these curves. Okay, so that's it for today. I hope that you find this video helpful. Bye.